Hi, everyone. Just to let you know, we're going to be recording this session, so we can send this on to anyone that wasn't able to make the session today. So thank you all for joining us today from wherever in the world you are. We're really pleased to see you here. This is a technical deep dive session where we're going to be running through some slides, but we're also going to be having some hands-on demos from the various presenters. We'll have a Q&A session at the end. So if you've got any questions during the presentation, please add them to the chat, either to everybody, or if you prefer, you can direct them towards Phil Miller and he'll collect them all together for us for our Q&A session at the end. We'll also pop up some poll questions towards the end of the call. So please do take the time to complete these because it really helps us focus future sessions and know if we're getting things right and talking about the things that you're interested in. So we've got a lot to get through, so let's get started. As you're probably aware, this is part of our digital acceleration series. So it's all focused on helping content creators gain more value from their content, creating new exciting experiences for your customers and hopefully getting some new business opportunities too. We had 3 events over last month focusing on ontologies, on entity extraction and semantics, and on next generation applications. If you haven't attended or watched any of those previous events, you don't have to worry. You don't need to have seen them for today's sessions to make sense, but we're going into a bit deeper technical area on some of those areas that we covered previously. All those recordings are available. So if you would like them, please just reach out to us at csm@marklogic.com. or put your details in the chat and we'll happily send them on. We also did a sort of 3 events in 3 minutes recap video. So if after today's session, you're really enthused, but you want to get some business stakeholders interested, that's a really nice video to send out just to give people an idea of the concepts that we're talking about and what we're trying to achieve. So the objective today, really, most of you are already MarkLogic customers, which is fantastic news. Some of you are not, some of you are new to the platform. So for those that you are MarkLogic customers, you've already got the power of many of the things we're going to see today in your data center. You've already got your content sitting in MarkLogic. So really the objective today is to see how easy it is to get started with this concept of smarter content, taking the data in your repository and enriching it with further metadata to drive new use cases. So you're going to see some practical examples of creating and managing taxonomies, how to get those into MarkLogic and the value that that brings, how to use our Optic API so you can combine multiple different types of query across the data models and see how powerful some of the partner applications can be to help get you up and started quickly. We've got lots of attendees from different verticals here today in different industries. So we decided to just use a really generic use case. So we're going to use a recruitment use case of job descriptions and job searches, just to give you an idea. But all of the concepts should be applicable to your industry. We're going to start with the team at Datavid, who are going to demo their Rover product and how you can ingest PDF job descriptions, use the power of NLP and machine learning to extract some entities from that content. Rover also allows you to really make a quick start with your project. You can overlay the Rover UI on top of MarkLogic and start building your platform very quickly. We'll then hand over to the team at Graphologi, who are going to demo their Graphologi product, and they're going to take you through those entities that have been discovered in Datavid Rover, how to manage those into an ontology and to create semantic meaning around them, and then hand that over to MarkLogic. And then in MarkLogic, Drew's going to take you through how to import that data, how to build up the queries, and to show you some of the value of the semantic search and the ontology and entity extraction. So with that, I'm going to hand over to Alex at Datavid and let you go.
I'm Alex Morton, working with Datavid. Yeah, I don't know if you've seen the previous session, but we have lots of things to show, many slides to go through, but we're going to try to focus on three main topics. First one, we went through during the other session as well, but I want to reiterate why would you use these technologies? Why would you do entity extraction, and present some use case where it was useful, and maybe bring some ideas of where you can use it to know why would you put in the work. Then we're going to show the Datavid Rover, but in the context of entity extraction, in the context that James mentioned with the job description, because Rover is much more than that and can have other use cases such as search and storage. But yeah, that's maybe for another presentation. And then I want to see, this is a deep dive session. We want to deep dive into the entity extraction, have a look under the hood of Rover, and how we managed to build the extractors we have there. So the first part, as I mentioned, is let's talk a bit about the use case. Why would you do this? Why would you invest time in getting entity extraction, and what can you do with it? One use case we saw quite a lot in our clients is discovery. So basically being able to discover your data easier, do cognitive search on top of it. This was one of the use cases we had, is a client from the life cycle industries, which had lots of R&D research data, which was stored everywhere in like file shares, SharePoints. So we built an app where you get those from different sources, you extract the text, you extract the concepts, and then you can make it easier for them to do more intelligent cognitive search on top of that, and easily discover and browse their data. Another important use case would be automation. Now, on top of the entities you have, you can put certain rules allowing you to automate some of the business processes you have. Basically, a use case we saw on that was a company that wanted to automate the business process of validating some permits. So they were receiving the permits in the email. They had to check, okay, are the permits fine for that location? Are they still valid? Look at the date, look at the location, look at the company. If everything seems fine for some business rules, push it through. Now, being able to extract those, you can then put your business knowledge on top, put the rules in, and then you'll automate that process. Another big use case would be compliance. So here we had, we tried to improve for a financial company, improve the fraud detection process, and it worked pretty much as automation. But after you extract and make your data more structured, you can then put certain alerts or have some indicative of how compliant you are at a certain point, and yeah, keep all that data and make sure you're always complying with the regulatory stuff. And of course, visibility. This is basically to have more visibility in your data. So extract and make certain links based on the extractions and the entities you make. You can link documents, and then you'll have more of a 360 view on your data. So you'll know that this document has same entities as the other one, and you know that this entity is a person, and you have his contact details from AD. So you can tie all this up together and have a better insight and better view of your data. So if we got into the use cases, we've worked in Datavid on all these sorts of use cases, and then we saw that some things are related, and we can start to build some accelerators to speed our work in doing this. And this is how the Datavid Rover was born. Now, first I want to show you just that light UI, and the idea will be to show what Datavid Rover can extract. And I'm going to open the demo for that. Let's hope the demo gods are in our favor. So we have, as James mentioned, we have some job description. In this case, I only put 3 job descriptions. They're all in unstructured format, PDF. I just dump data in a PDF. That's it. And we have the Rover Lite UI. It doesn't have the search functionalities enabled. It's just here. I've just put it to show the extractions. And I'm going to put this document in the documents in an S3 bucket to get processed. Now, Datavid Rover will actually be able to support more ways of loading data from your local drive, from cloud, AWS, Azure, might be able to support Google in the future as well. So they already processed. They are like 2-page documents, 1-pager, so it went quite fast. And let's open and see what we got from the extractions. Now, it's a simple document, and this is what we apply the general model on this document. So basically, a model that knows how to extract things like money in this case, person, which I see got it wrong, dates, and location. Now, you can already see and you got dates such as also in the format of a date, but also such as periods. You can already see some use cases where you would start already to make use of this information in filtering your job descriptions, like categorizing it per salary, or categorizing it, having already the dates extracted. You already have more structure in your data. Now, this is using a general model built on top of lots of Wikipedia articles. So it knows how to extract general stuff that are not specific for this domain or this problem. But we also, for this job description use case, we also built a custom one, which besides the fact that it knows to extract, again, dates, organizations, products, it can also extract programming languages. And this is the custom name entity recognition and the custom NLP that I'm going to talk about and show you how it was made. Now, yeah, these are just the general extractions, and you can see the programming languages extracted here are Perl, Java, and it's all Perl again somewhere down. I've put one with more programming languages just to show that it can do much more than just 2 programming languages. Didn't get them all, to be honest, but yeah, I'm going to get to that as how you measure and how can you improve your extractors in time. Yeah, so yeah, let me then go back to the presentation and show you a bit, do a better deep dive on what you saw here and explain a bit what's under the hood of this. Now, the Datavid Rover is basically a set of APIs. So we try to have it as modular as possible, so we can change a few components if we need to. Basically, you have functionalities, APIs for each functionality, like storage, upload, different extractors that I'm going to tackle in the next part, MarkLogic, of course, and then also an data orchestration to orchestrate the entire pipeline of processing a document. Also, it's going to have a UI. It's going to be either this light bar for the extraction, but you're going to have a more complex UI to be able to also do all sorts of search and visualize, have a graph visualization of your entire data. Then diving deeper into entity extraction, we described in the previous session that we are doing, in most of our cases, 2 types of entity extraction. Either entity recognition, which is based on some of tag data. As I mentioned, the general model is based on tag data script of internet, and the programming language one is based on, again, some Stack Overflow data, and some of them had to be tagged manually as well. So there are 2 types. There's also what I mentioned, entity recognition, entity linking. So basically, entity linking is going to be based on rule-based information extraction. So basically, you're going to write some rules. If the pattern is matched, then you're going to say, okay, this token is category 1. And entity recognition, which was the model-based one, it's basically you training a model to figure out that whenever you're going to see token 2 next to token 1 and token 3 is going to be either category 1 or category 2, and you're going to take the one with the highest probability. So jumping from the theory, this is basically known in the NLP field as named entity recognition. So basically being able, giving a set of tokens, like a sentence, being able to correctly categorize some tokens based on some entities you need to extract. Like in here, person, location, ordinal, date and time. And there are lots of open source state-of-the-art models that can do this for you, but yeah, have a limited set of entities. Because you have a limited set of entities, you might be in the need to build your own custom named entity, as we did for these programming languages. And the first and arguably the most important part of this will be your data set. So you're gonna need to either find data in your data storage inside your company, find tag data, or even start to use a tool for tagging, which can do parts of it, can be automatically tagged, but then you're gonna need to have someone to verify it. Because there's a concept saying that garbage in, garbage out. So you can have the perfect model, but if your data is bad, then your model is just gonna learn the things that were wrong in your data and use them further in predicting. So you're gonna put, if you're not careful on how you manage your data set, the named entity for this is not gonna work. After you have your data set, you're gonna need to train your model. So basically there are lots of more in-depth definitions of training, but if you look at just a higher level, basically you're gonna have a training data, which you're gonna have the text and the assigned label for each token, and you're gonna gradually continue to train a model, and then you're gonna evaluate using the gradient descent function, and you're gonna try to minimize that loss your model is still doing, and try to have a model, generic one, that is gonna try to predict as better as possible with the data you have. Training a model requires also some parameter fine tuning, because the model is going to train in epochs, and you're going to use batches in this epoch. So you're going to train batch by batch. So you can play a bit around with the batch size and the number of epochs for training the model. There are tools for doing that as well, or trial and error, and yeah, keep on improving it. You're going to have your model, but you need to know how good it is. You need to test it out. It's not as a normal development work where you build something, you see it works. You need to measure it. And for that, there are industry standards for measuring information extraction, which is the F1 score. Now, the F1 score is made of precision and recall. And basically, precision means that out of the ones we had to extract, how many tokens are correct. So we had to extract 9, and 6 of them are correct. And recall is out of the ones we had to extract, how many did we manage to extract. So recall gives more of an idea of completeness, and precision more of an idea of correctness. And the F score is basically just the harmonic mean between these two. So it's going to try to give you a direction of how complete your extraction is, but also how correct it is. Then images and visualization tool you can use for this is the confusion matrix. So basically, you can put on one dimension what your model classified, and on another dimension what is the actual correct value for that. Okay, so ideally you want to be on the diagonal. So of course you want your model to when it sees an actual dog, to classify it as a dog. It's the same. But then you need to look at the places where your model is confused. That's why it's called a confusion matrix. So whenever apparently your model, whenever it sees a rabbit, it seems that it classifies it as a cat. So you need to work on those areas and see, okay, what can I do to shift that towards the diagonal. Now, going further, so this is the entity recognition part. So basically, this is how you have some tag data, and you try to to use that tag data to create a model and use it on future data points that are going to come and extract from those. Now, what we also do in Datavid and in Datavid Rover is entity linking. So basically doing extraction based on some existing knowledge base, or in this case, existing ontologies. That might be pretty easy if we're thinking without keeping in mind the context, because we can just take the words from your ontology, do a string match on the documents, and then we're going to say, okay, we extracted the concepts from your ontology. But there comes context in play, where you can see here the word bank can have multiple definitions depending on the context. So you would want to do more than just a normal string matching or a fuzzy match on a string, and you want to take into account the context when you apply these extractions. For this, you can actually make use of the generic NLP. So we went over the named entity recognition. So let's say we take a sentence. You can pass it to a generic model to get the named entities. You can get the part of speech tagging. There are state-of-the-art models for that as well. Just going to tell you that Datavid is a proper noun. Those are a verb. And then you can get also a dependency tree of this sentence. So from this, you can understand that the verb providing is actually talking about Datavid. Most data is talking about there is referencing businesses. So you have this dependency tree. So you know in a sentence which word is related to which one, to the other tokens. And then you can actually have a context-aware extraction by writing rules, which are going to also use this dependency tree. So you can have, if you're going to have, for example, the concept person, which we might define as being a noun, a proper noun, in the same dependency, in the same sentence as the verb, which means that has age, and also that age is related to that number is related to the age verb. We can say, okay, this rule matches, it makes sense, it has the context we defined, and then we can infer that this is an adult, and we extract it as an adult. But to be able to do this ontology extraction, you need to build your knowledge graph, and the guys from Graphify are gonna tell you how you can use Graphologi to do that.
So who are we? So I'm Paul Appleby. I'm co-founder of Graphify. We provide knowledge graph tooling. So we have two products, Graphologi and Easy Graph. We're focusing on Graphologi today, and we went over various aspects of Graphologi in the previous demo. It's a service. It's software as a service. You can sign up on that link you can see on screen. You can just go there and give it a trial. And we've got a LinkedIn group as well where you can go and it's a new group, but we can discuss it. So after all of this, feel free to go and have a try. It's 2 minutes to sign up. So a brief review of the last demo. In that we covered a few points, mainly around the standards. But the first and most important thing is the idea of identifiers and IRIs. So in a semantic world, this is probably the most important thing you can do is give things identifiers, and in the semantic world that does mean an IRI. Now, some people will call that a URI. They're very similar. IRIs are essentially the internationalized version of a URI. So there's one on screen that you can see there. It's obviously a made up one, but that is basically the IRI for a concept called programming language. And everything you see in Graphologi essentially has that. That's precisely how RDF works. And then we have the standards that we touched upon, and again, we'll be seeing those in action today. SCOS, which is for taxonomies, SCOS Excel, which is an extension of that, which allows for richer modeling of labels themselves, so the actual labels that concepts have. And then on top of that, we have OWL, which is for modeling your domain as an ontology. So those are absolutely key to a semantic system, and are omnipresent in any system that is basically RDF or semantics. So to build on what we saw from Alex, where essentially he's running the analytics over some content, to maybe bootstrap the idea of creating a semantic model and some data to go into some taxonomies. What do you do with that stuff? How does that actually help? So there are various things, and if you think about job descriptions especially, I think they're probably more complex than many other kinds of document because everybody approaches them differently. So to engage with users and to get better results, you do need to be smart. So for instance, so what are some of the challenges? Well, in one document you might see all sorts of variations. You might see abbreviations such as MS for Microsoft or JS for JavaScript. Then there are different ways of calling something lots of people use the same synonyms for the same thing. So semantic web, knowledge graphs, and linked data. And there are many examples that you can come up with for synonyms, and we'll show a bit more about that later. And then you've got jobs which might not mention a particular technology. So again, it might mention the XML stack. Well, what does the XML stack mean? And in that respect, it probably means things like XML, XQuery, XSLT. So even if something doesn't mention it directly, you still really want to be able to make that correlation between the two things. And similarly, in another way, grouping technologies together might be very useful. If you see a bunch of XML technologies, for instance, like XML, XSLT mentioned in a document, that probably gives some weight to what that document is about. And so by being smart and making more connections, you might be able to make an assumption that it belongs to something like the XML stack in a more accurate way. And then there's the situation potentially where, say, a person is interested in a particular field. And in the example we've got on screen, it's customer relationship management. Well, obviously, that is applicable to certain companies. So it may be that jobs from certain companies are of more interest to that person than other areas. So there are all sorts of different questions we can ask off the content that simply doing a search on it is not going to give you any answers. And you need to make connections between what the person is doing and what language they're using, what the language of the document might be. So the first thing to do essentially is to model your domain. And what that means for us in this instance is creating an ontology and some taxonomies to supplement your ontology. Many of the properties in your model will take values from a taxonomy, and as we saw earlier, one of those examples might be a programming language. So you'll have a taxonomy of programming languages. So we've got our model, we've got an ontology, we've got some taxonomies. What does that allow us to do? Well, it allows us to start connecting the things together like we suggested earlier. So this is an example of the visualization in Graphologi, and visualizations are great. Certainly when the graph isn't too complicated, they're great at getting across the idea of the relationships between the nodes in that graph. And obviously a graph is made up of nodes and edges. And in an RDF graph and a property graph as well, to be fair, the edges are as important as the nodes themselves. Those relationships have meaning and they're first-class citizens in this world. So we can see that from the example we've got in our graph here, we can answer questions, simple questions in this instance, like find me jobs which mention skills related to the XML stack, because we know that XML is related to the XML stack, or find me IT companies where my XML skills might be useful. And in this instance, well, we know that MarkLogic and XML are complementary to each other, so they're related, and we hold that in our model and in our taxonomies. And so that's a simple example. A slightly more complex example. So in this instance, we've got two steps to get to the answer we want. So the question in this instance is, given I have a particular certification, and obviously if you're a job seeker, there's a good chance you'll have, say, professional certifications, what roles might be suitable for that certification? So you might just have got your shiny new AWS certification or something similar, and you're looking for a new role that, to get that big pay rise that you're after. So in this instance, well, we can see that a certificate in risk and information systems control is connected to the area of risk management, and risk management in itself is connected to a role, risk management modeling manager, and those roles themselves may be something that's come from text analysis of a whole set of job descriptions or job titles, so that again you can build potentially a taxonomy from that analysis, and the curation of that analysis to ensure that that the taxonomy is correct. But in this instance, therefore, it allows us to make 2 hops and answer a slightly more sophisticated question. And there's no real limit to the number of connections you can use to answer questions. The more connections you've got, the more complex questions you can generally answer. So obviously that's the job side of things. We need to say, well, what does a person look like, a user look like in our system? Now, in our ontology, we've modeled a person. We just got the one example on screen here. It's Mary Smith. So where you manage your entities like people is an interesting question, but for this instance, we've created it in Graphologi. But what it allows us to do and to show is that we can say statements about a person as well. So in this instance, we can see that Mary Smith has a particular certification, has worked for a couple of companies, and has various skills, such as working with MarkLogic DataHub service. And so we've modeled Mary, and the important thing here is that those relationships and those entities, such as the XML stack, those are the same concepts that we use everywhere else in the system. Everything is connected. So those chips that you see on screen, they have IRIs behind them, and that's how we make all of the connections. Now, another important aspect of many systems is supporting multiple languages, and again, in the world of jobs, this is key, really. There are various considerations. It's very important, really, that your taxonomy application can support multiple languages out of the box. If it can't, obviously this is a non-starter. The standards themselves support it. RDF supports it. Graphologi supports many languages. And if you can do this, then obviously this allows you to do things like search in one language, but find results that are in another language. A job may be posted in English. The job seeker may be searching in French or Russian, whatever language is their local language. And the connections and a multilingual system allows you to make those connections without having to do horrible translations or expect the user to search in languages that they're not that familiar with. So the example we've got on screen here is the idea of the customer relationship management concept, which is that in English, and on right, that's its Dutch equivalent, which I'm not going to attempt to say. But essentially, those are 2 labels for exactly the same thing, and that's key to the whole semantic sort of graph idea, that it's a single concept that can have many labels, but it is absolutely one thing. And you can see above that in that table, that's a representation of the underlying triples that you would see in Graphologi for this concept. And you can see that there are 2 pref labels, one in English and one in Dutch there, and various other relationships. And then finally, and very important to the whole thing, is the lifecycle management. So we saw Rover doing some text analysis, and in this particular use case, that might be the first thing you do, and you may well do it later on in the life cycle too. But if we in this instance, let's say we've taken the data from Rover, and we use that to create an initial set of taxonomies, for our roles, maybe for programming languages, and for various other things. It may be geographical locations, that kind of thing. So in Graphologi, you create your taxonomies, and then you use that to essentially bootstrap your application and do that by integration into your target system. So Graphologi has various means to send data to a target system. So let's say that you've got a system and it's built on top of MarkLogic. So you've got all of your semantic triples have been sent from Graphologi into MarkLogic, and you've got your application built on top of that. And then essentially you're into a BAU, business as usual life cycle. You've got your application up and running, and you're probably getting feedback from users. Is this a useful review? Is this a useful job suggestion? Those kind of metrics coming in from users. So you'll probably take that information, and then with a little bit of processing, you'll actually feed that back into suggestions to your taxonomy, so that perhaps a new programming language has cropped up that you didn't have in your taxonomy, or your text analysis didn't pick up, but it's starting to crop up in job descriptions. So you would feed that in maybe as a suggestion to your taxonomy, and then within Graphologi you would essentially go through a curation process. So somebody who may be a taxonomist would go through and review it, and then either accept or reject the suggestions, and then deploy that back into the system. And you go through this life cycle continuously. And that's an important part of the process, that taxonomies are living things. It's not a case of you do it, you deploy it, and you forget it, certainly not in most situations. And one other important aspect of all of this is that concepts are born, but concepts also die to some degree. The term here is deprecation. And this relates back to the idea of IRIs, that if you've deployed an IRI into your system, you don't really want to delete it from the system because legacy data will refer to it. So the idea of deprecation, essentially making something not usable going forward, is really the way to go. Deletion is not something that you necessarily want to do from your graph in this situation. A graph is a very complex structure, and deletions can be quite hard to manage, to make sure that you don't break existing data. There can be lots of inbound and outbound connections, obviously, from a node. And certainly in this situation, it probably makes more sense to deprecate than to delete. So just to touch on a bit more about the integration options, in Graphologi, you can do a push, which is done via webhook, and essentially you set up an endpoint in Graphologi, and it's in control of the taxonomist when they push that data. And that's an important part, again, of the life cycle, that you would make those changes, and it's up to the taxonomist or some expert to decide, yes, this has been updated and it's ready to be deployed to the production system, and they push the button. Alternatively, of course, your system can pull data through APIs, and that may have advantages itself, but you do come into the problem of knowing when the data really is ready to pull. So in many situations, a push would be a better way to do it. Okay, so if I switch over to the application itself. So this is what you see when you come to log into Graphologi. Obviously, you would go through a registration process initially to get to this point, but once you log in, you go in and you've got a subscription. So in this instance, I've created a subscription for this demo, and this is what you see. You've got the vocabulary manager and the ontology manager, the dashboard where you manage users, groups, and integrations, and then the account stuff, your usual account bits and pieces. So we'll just go into the ontology manager first, and we just have one project. And that's how Graphologi works. It's all project-based, and permissions work at the project level, so you can control who has access to a project and who can do what in there. And if we go in, we've only got one ontology loaded in this project. You can have multiple ontologies if you need to make connections between your ontologies themselves, and that's quite a common thing to do. So we'll just go in, and it's a very simple ontology. We can see here that we've got a few classes. So we've got programming language and a few subclasses of it. So object-oriented programming language, for instance, certification, person. Basically, this is your model in the flesh, so to speak. And then you've got various kinds of properties. You've got object properties, which are relationships between entities. So you saw some of these on the slide about the person. has certification, has skill, has worked for. And if we look at these, you can see that it's possible on these properties to define domains and ranges. So that what that means is the domain means that the property essentially belongs to things of that class. Now, in OWL, this is done through something called inference, where essentially if you see the property, you can infer that the subject is a person. But Graphologi itself uses it in a slightly different way, more to assign properties to entities, and I'll show you that in a bit. But the principle is the same. And you can have a range, which essentially then means that's the kinds of things that the property can take as values. So in this instance, certifications. So that's a very simple ontology that's for this demo. They can obviously get quite complex and quite large. And we'll just switch over to the vocabulary manager, which is where our taxonomies are. So we've got 3 projects here. We'll go into the MarkLogic demo project. So you can see here we've got quite a few taxonomies set up: business processes, certifications, IT companies, and you can have as many taxonomies in here as you like. Each one is essentially technically a SCOS concept scheme, and obviously everything in it are SCOS concepts. On the right, there are no collections in this example, but essentially we support SCOS collections as well, and they can be ordered and unordered, and they can be very useful as well for grouping stuff together. And we touched on collections slightly in the previous demo. So we'll go into a couple of the examples here, and some of these would potentially be used to do your entity extraction. So programming languages, was one of the examples that we saw, or may come from your entity extraction. So we'll just go into there. And so this is what it looks like in your taxonomy. I mean, this is a very simple taxonomy. There's not much in the way of hierarchy. We've got a couple of examples of C# and more specific versions of C#. But in this instance, I say it's a fairly simple one. They can get very deep and very, very complex. And if we take an example here of Java, for instance, I think the interesting thing here is that we've assigned an additional class to this concept. So not only is it a concept in SCOS terms, it's also an object-oriented programming language. So that gives us more information immediately about what this thing is, and can be very useful for making those semantic queries and those connections if you are looking for things that are object-oriented programming languages, for instance. And if we go back to the project and type in CRM. So one of the things we touched upon was abbreviations and different ways of describing essentially the same concept. So at this point, I'm searching across the entire project, and it's found that CRM, it's recognized customer relationship management as a concept, given that. And this is essentially an example of using those synonyms and those aliases. We can see that CRM is actually an alternative label for customer relationship management, and obviously Graphologi itself is using that information when you do the searches. And if you would have obviously found it if you'd searched for customer relationship management. But again, you can have as many alternative labels as you need to describe an entity. And that may include misspellings as well. Quite often, things like hidden labels are used for misspellings, and hidden labels generally in SCOS terms are never surfaced in a UI. They're there for background processing, so they can be perfect for things that are potentially spelled in slightly different ways, and quite often misspelled as well. So one of the other things we mentioned, if I just go down to programming stacks. We've really got one here, and we'll just go into it. So this was an example that we had on the slide, showing that maybe somebody might be searching for jobs related to the XML stack, but the jobs themselves may contain the actual skills or technical terms, such as XML and XSLT. So our taxonomy allows us to essentially create these relationships. Now here we have related matches to MarkLogic, the company, and to XML, and so we've got various technologies, and those related matches could be to anything in the project. And in SCOS terms, related match is used to connect concepts in different taxonomies. There are a set of properties that you generally use if you're making connections within the taxonomy. So in this instance, if we click through to XML, for instance, well, yeah, it takes us through to here. And so we're into the markup languages taxonomy. And here itself, we can see that XML has some narrower concepts, some various markup languages based on XML. And again, some related concepts. XML is obviously related to SGML, if you're old enough to remember SGML, and I certainly am. And then there are other related concepts like HTML, which again has its roots in SGML. So those are the kind of connections you can make, and obviously this can feed into query expansion in downstream applications. You know, if you're searching for XML, then you may in this instance be, look for documents that contain these technologies such as SVG, XBRL, and so on, and it allows you to do that. So in our slides, we also saw our person, Mary. So this is Mary in the application. And we can see that we've given Mary a class of person, and in a similar way to the programming languages, this potentially allows us to make queries to find things that are people in our knowledge graph. And if we go down, this is where the relationships from the ontology are being used to add additional properties to the concept. So SCOS itself goes to a certain level, but they're very generic relationships, really to do more accurate or more specific relationships. This is where you need to use your ontology to say more specific things about particular concepts. So here we have 3 properties: has certification, has skill, and has worked for, that we saw from the model and being used here. And as we saw, I think the example was MarkLogic DataHub service. You can see there that hopefully you can see that on screen. That's the URL or the IRI that essentially is pinned behind the MarkLogic DataHub service. So again, we're making that connection via the IRIs. That's how it's done. So just one more example on this. So if we just go back to CRM. So on our slides, we also mentioned about support for multiple languages, and we had the Dutch example there. And so we can see that here, that we've got 2 different labels for the same concept, customer relationship in English and the Dutch version, which I'm still not going to say. And again, you can have as many labels as you like in as many languages as you like. Now, one of the important things potentially when you're working in a multi-language setup is the kind of completeness of your data. What you don't really want is gaps potentially. So if, for instance, we look at the statistics for this taxonomy, and obviously it's a very small one, we can see that we've got 3 English labels and 1 Dutch label. And this might well tell a taxonomist that we need to do some more work to bring the Dutch language up to speed with the English labeling. And the question is, well, how do you know which ones are missing? So Graphologi allows you essentially to switch the view language that you're viewing in. So we're looking at exactly the same data, but in this instance, we're looking at it from a Dutch perspective. So everything you see that's now highlighted orange is telling me that those things do not have Dutch labels. So it immediately shows you that there are potentially gaps. And so as we saw in the statistics, we've got 2 concepts there that don't have labels in Dutch. So that potentially then allows you to go through, again, your curation process and your governance process of making that more complete if you need to go down that road. So we touched on lifecycle governance. And if I go back up to programming languages. So we mentioned about making suggestions. Now within Graphologi, this is at the taxonomy level. You can do this down at the concept level as well, but these examples are essentially at the taxonomy level themselves, or the concept scheme level. So we can see here that we've got a couple of suggestions that have been made. One for essentially to add the label basic. So obviously, but basic is a programming language. It is an oldie, I think it was the first one I worked with many years ago. And so somebody made that suggestion, and anybody essentially who's part of the team working on the project can make suggestions. And then somebody's come along, in this instance, it was me as well, and made a comment. And that discussion could go on. Everybody can participate in the discussion. So you can have a discussion thread to go through the process of discussing whether something should be accepted or rejected. and in this instance, it's been accepted. And we've got another one down here, which as yet hasn't been accepted. Somebody suggested PHP. That's different kinds of suggestions. Some are immediately actionable, things like new concepts, moving or deprecating. And if you push the button, the system will do it for you. So I'll say, okay, yep, we're going to add PHP to the system. I'll say, cool, and add. And then hopefully you can see that coming up to say something's been added. And on the left, you can see that PHP has been immediately added into the system. So as we mentioned in that life cycle diagram, yes, maybe PHP has been found to crop up, and we want to add that into our system. And this is essentially one approach to the governance of and thinking, yes, okay, this is how we're going to do it, and how we're going to accept new terms. So if we just go back into let's go back into Java. So we mentioned about deprecation. Actually, we'll go to action script, because I've already deprecated this one. So action script, I think, came from Flash, which is now pretty much obsolete. So this is where this concept has been deprecated, and this little button up here essentially allows you to deprecate and undeprecate. And the main difference, if I go back to Java, you can see here everything has got these plus buttons. It's still, you can still make changes. When something's deprecated in the system, essentially it becomes almost read-only. There are a couple of things you can do. You can still delete it, obviously. But essentially it becomes a read-only part of the system. So as we mentioned earlier, in that life cycle, once something reaches this state, you'd probably hide it from your UI, but it's still there in the system. But that deprecation information is there, and it has its own special triple. If you can see this on screen, OWL deprecated. So that's actually from the OWL language that we use that property. So we mentioned about deletion to say deletions. Yes, you can do it. Maybe not the right way for a lot of situations. And then just to finish off, we go back to the project page. So we mentioned about integration. So, okay, I've done my curation. I'm ready to send my data across, or am I ready to send my data across? So if I click the synchronization button, I've set up an integration in the background, and that's done through the dashboard. But if I click this button, essentially then I can select from one or more integrations. And obviously you may want to send this data to more than one system, or to a development platform and a production platform. So you can set up multiple integrations if you need to do that. So I'll select this one, and then the system takes a look and says, right, okay, what's changed since you last did this integration? And we can see that a couple of the taxonomies have changed. IT companies has changed, and programming languages have changed. Obviously, we just added a programming language, so that would be included, and it gives you a count of the number of things that have changed since you last ran it. So it's then within your control, essentially, as to what to send into your system. And by default, everything is ticked, but it's within the taxonomy's control as to what they send. And you essentially push the button, and off it goes down to the endpoint at the other end. So that then kind of completes the process and the life cycle, and that's kind of more or less it. So yes, take your taxonomy, curate it, put it in, go through that life cycle, and then over to Drew for the next stage, I think.
So I'm going to give you just a high level overview of data harmonization and discovery in MarkLogic. We have a couple other sessions that go deeper into aspects of this. However, we're going to focus on the use case right now for auto tagging and doing data discovery based on query expansion. So as some of you may know, MarkLogic has a framework called the DataHub. And what you can do is load your data into MarkLogic in any shape as it comes. So whether it's RDF triples, an ontology or taxonomy coming from Graphologi, or it's the PDFs or XML for the job descriptions as we showed earlier, we can ingest that as is and start building initial value off that data. Part of that workflow, we have tooling within our data hub to do harmonization and canonicalization of that data into known business entities. And what that does is gives you a well-formed, curated set of data to access downstream from either your transactional apps, or if you're doing reporting, facilitating additional machine learning or AI, or any other downstream systems. So in this example, we have a combination of documents and triples. So we have documents to store the long form information about the job posting. So things like the titles, the responsibilities, wages, industries, etc. We also have the supplemental graph coming from Graphologi around the topics and concepts that relate to this particular domain. And we can build rich relationships between these items. One thing to note is that MarkLogic, when you set it up, is always a multi-model database. So you can load in documents, triples, and project views of your data into rows and columns without any additional decision in the beginning of your setup. We're going to talk a little bit about entity extraction today. We can do entity extraction in a few ways. We can provide, this is dictionary driven, so you can programmatically construct your dictionary. You can do it based off of text files like a prepared spreadsheet, or we can use a SCOS ontology, which we're going to be demoing today, using the SCOS ontology built out within Graphologi. There's two ways to do entity recognition within MarkLogic. We can do enrichment, which identifies the concepts directly in the body of text and wraps them up. So that's good for text highlighting or doing links out, as you may see in some other websites. Or we can do extraction, which will just provide a list of the found concepts. And this is good for building lists of keywords or topics for faceting. Once we have the data curated, in terms of the consumption, MarkLogic Optic API is a single API to address any of these indexes at the same time. So you can query documents, rows of data, or the graph all within the same query. Really focuses into the particular data type. So it gives you tooling to query against each shape of this data natively. It's developer friendly, and again, it can address any of the indexes or types in the same query at the same time. We're going to jump out to our demo now. I'm going to show you MarkLogic's DataHub Central. So this is a user interface built on top of the DataHub framework that allows you to curate and define your data workflows. When you log in, you're greeted with the splash page here, and you can load data as is, you can model your canonical entities, and you can curate your data. So we're going to load this data. I've set up a job posting load step here. So we're saying we're going to load in some XML files. The target format's going to be XML, and we're going to give it some target URI prefixes here. I'm going to load these off my file system. However, this can be loaded programmatically through various integrations if you'd like. So once the raw data is loaded in, we can start browsing it immediately. It's indexed in our universal index, so that means that you can do free text search against it or search with specificity if you need to. So I'm just going to search for engineering, and we can see we have some hits on those particular topics. We can go into the raw data and see it as is. We follow an enveloping pattern too with our data, so we can store metadata surrounding the workflow, the data sources, etc. And then we store an instance object where we would maintain the version of the data that we're making presentable to the end users. In this case, the next step is going to be modeling the data. So we're going to create a canonical model, in this case, job postings. We can add this model, we can give it fields and properties, so titles, description, the posted date, the close date. We can add additional properties if we'd like by giving it names. We have simple types to start out with, or we can do structured entities if we want to go into a more rich data model. We also have additional types if you need more string types, number types, or data types. And in this case, we have a structured property under it called entity tags. We can have multiple entity tags here. And we have the type of tag it is, the text of that's found within the body of text, the normalized text, which would come from the preferred label from the dictionary, and the ID, in this case, the IRI for the term, which will also help in searching. The next step will be curation. So we have a mapping step here, and this is where we're going to take our raw data as is and map it to our data model. And we can see the raw data on the left, and we can see our entity that we defined on the right-hand side. You can easily select fields within the raw data. It will provide an XPath for that data automatically for you. Or if you'd like, you can hand type the XPath out. Additionally, we can call functions from here. There's a set of out-of-the-box functions, which are quite rich to do common tasks. So here we have a parse date function for converting the string date to an ISO 8601 date. Additionally, we can extend the functionality of these functions by writing a little bit of code in the background. In this case, I wrote a function called extract entities that you pass in a body of text, and it will auto-classify this contents based on the Scots dictionary that was provided. So if we hit test here, we'll see the mapping of that data right over to our canonical model. We can now run this. And in a few seconds, we'll have this data harmonized and viewable within our Explorer. We can see, since we defined a canonical entity, we have a nice table view here for seeing the contents. We have faceting on the left-hand side here. We have data that was directly mapped, facets directly mapped from the data. So we have the status and the industry. However, these entity tags here are what we saw in the Scots dictionary that was built out. So we can apply this facet and narrow it down if need be. So I'm going to take you a little bit behind the scenes of what's actually happening. You can use the DataHub Central with low to no code ever being developed. But in this case, we had to write a little code to do the entity extraction. So if we had a turtle file just given to us, or how you would be writing the integration between Graphologi and MarkLogic, basically, you would need to take that file and insert it into the graph. And it's a simple one-liner to break up that file and insert it into the graph. Once it's in the graph, you can query the graph natively with Sparkle, which is the industry standard query language for querying graphs. And here we can take the IRI for that programming language and find all the relationships that are associated with it. So we can see we have the top level concepts, what they are, what scheme they're part of, what's the preferred label, the created dates and modified dates. The next thing we do based off of that ontology is generate a dictionary. And by generating that dictionary, we just point to the graph that we loaded and convert it using the entity API to a Scots dictionary. And once that's converted, it stores the dictionary within your content database, and you can use it for entity extraction. So in this particular case, I'm looking at this job posting here. I'm going to pull the job description out, and I'm going to extract the terms within here. So we can see that we have the terms for identity access management and IAM coming out of this job description, similar to how we saw in the facets. The next aspect is using MarkLogic's Optic API. And this is really useful if you're building web services, or you're building reports, or even integrating with some of your other tool chains. The Optic API, you can write server-side JavaScript or XQuery with it. You can also use the query DSL, which looks similar to the JavaScript implementation, and post that to our out-of-the-box REST APIs to pull data back automatically. For this particular use case in this query, we're going to take the IRI for object-oriented programming languages. So I'm going to be looking for jobs that are object-oriented. I don't care if it's Java, I don't care if it's C#. I like object-oriented programming and I want to find a job for that. We're also going to take metadata from those two views, the postings that we saw, as well as the tags that were enriched within the data feed. We can access the graph by calling from triples. So we're going to give it a pattern. So we're going to want to pull out the languages where the RDF type is this IRI for object-oriented. Once we have that information from the triples, we can then start joining those metadata views with the graph view directly here. So we're taking the postings, we're joining in the tags based on the fragments, the document fragments, and then we're joining in the triples based on the identifiers of the tags that we marked up, and then the languages that were extracted from the semantic graph. So if we do that now, we see that we have jobs that came out, job postings, with both information from the views as well as the semantic graph. The additional interesting thing that you can do with Optic is the same query, but we can do aggregations, rich aggregations, so we can group things by, and we can see that in this case, 28 positions were for lead IM engineers. We have a few others here for senior IM engineer, etc. So that concludes what we can do, the brief demo surrounding Optic API and the entity extraction. We have more in-depth presentations if you're interested surrounding the inner workings of Optic API and management of graph, document, and views within MarkLogic. Thank you.
Okay, so I think, our previous events showed the value in creating smarter content. So, we've talked about enriching content with entities, which gives you those hooks to understand the context of a document. We've talked about linking those to an ontology, so you can create powerful applications. So I think we've shown the value of creating entity extraction and the semantics around the documents. Think about the value that you can pull out of the content by understanding that context a bit more and relating it to those taxonomies and the ontologies. And think about what you saw with Graphologi as well, which I thought was really interesting, is that we were classifying the content, but we're also talking about, in this case, it was the job seekers, but you could imagine that was your customers. And how do you bring those two data sets together, and what value can you have of understanding how they're interacting with the content and the things and the recommendation engines that you can build off the back of that. So really the point of today was hopefully showing you it's not difficult to get started. We showed Datavid how quickly you can get going and start bringing data in and looking for entities. Graphologi shows you how quickly with their UI you can start to build taxonomies and ontologies and push those to MarkLogic. And I think Drew showed you how quickly we can start using the Optic API to provide some really powerful searches. And the DataHub Central is a nice UI, low code, no code way to start playing with that and proving it out. I think we also mentioned a couple of times garbage in, garbage out. That's absolutely true. But you can also use the power of MarkLogic to help you cleanse that data. We've got a number of customers that have brought their data into MarkLogic. They've used DataHub to harmonize and cleanse that data and then pushed it back in again to help their modeling and improving things. So all of this session is recorded and we will send that on to anybody that's registered. We'll also follow up with a blog post to give a little more background to this and maybe some of the example queries that Drew went through. So with that, I will hand over to a Q&A. I've seen lots of chat coming through on the discussion. So I think we've answered most of those questions, but if anyone's got any more questions, please feel free to come off mute and ask the experts.
So I had one question come through, which is the URL for the free trial for Graphologi. So what we'll do is we're going to put that into the follow-up emails to these sessions. We'll put some information where you can get the free trial for Graphify, as well as information on Rover and Graphify themselves. So we'll make sure that we do that. We'll be releasing probably a blog to sort of round up this series. And we're going to be using your answers in the poll to inform the next series, which we're hoping to kick off in September after the summer break.
Wonderful. Well, we truly hope this session has been useful and informative. We'll certainly look at your poll results and learn from those. And if there's any information that you've seen today or any more information you would like, feel free to reach out to csm@marklogic.com and we'll certainly follow up. And I'd just like to thank all the presenters today. I think it was a fantastic demo and I hope you saw some value from it. So thank you, everyone. Thank you for your time, and we'll see you at the next event.